Okay, we get to start chemistry today with history lesson, which is kind of unique in chemistry. We don't get to talk about history very much in chemistry. The first person we're going to talk about in our history lesson is a Greek philosopher called Democritus, and he's doesn't even have a first and last name. He is the first person that we give credit to for the word atom because he is the first person to think that matter is made up of very small particles, indivisible particles, which means you can't break them apart, called atoms. Now, I think the most important thing about Democritus is that he was a thinker. He was thinking about this. He did not do any experiments. He just kind of sat around and thought all day. We're going to jump way ahead in time because now we're all the way from the Greeks to the 1900s, late 1800s, to a man called John Dalton. Now, John Dalton looks like he's thinking here, which I think is ironic. However, he was the first person to actually propose a theory about atoms. And we know that theories in science are based on experiments and observation. He didn't say much different from Democritus, actually, but he experimentally proved the existence of atoms. And he said that these atoms are just little spheres because he didn't really know much else about them. This was the start of a period in time in which now they were ready to do experiments on atoms. He experimented with gases, Dalton did. He discovered what's called the law of definite proportions, and that's how he discovered these atoms in spheres. The next person that we're going to talk about is J.J. Thompson, and J.J. Thompson discovered negatively charged particles called electrons. And he was the first person to suggest the existence of what's called a subatomic particle. And a subatomic particle is just a particle that is below the atom level. And his subatomic particle, of course, was the electron. It has a negative charge. And he discovered these by working with cathode rays. This is what a cathode ray tube looks like. And like Dalton, it is filled with gases. They were studying gases at the time. And you pump basically electricity into it, and the cathode rays go through. And when you hold a magnet up to it, he discovered that these cathode rays bent towards the magnet. Now, here's an example of what this looks like. So there's the magnet held up to it, bending the cathode rays. So he's going to flip the magnet around, and you can see that when he flips the magnet around, it's now being attracted towards it. So this magnet, if you flipped it around the other way, made it bend in the other direction. And that's how he discovered that these electrons have a negative charge. He did not know what to say about these electrons, so he just drew the atom and he said that the electrons were located somewhere inside the atom. Now, they call this the plum pudding model because the plum pudding or the pudding would have been in between here and it would have had a positive charge because they knew that electrons were neutral. I don't like the plum pudding model because I've never eaten plum pudding in my life. So I like to call it the chocolate chip cookie model because that's what it looks like to me. There are electrons scattered throughout, and the electrons are like the chocolate chips. Now, this was fine, but there were still a bunch of scientists trying to explain this a little bit better. And one of these scientists was Ernest Rutherford. And Ernest Rutherford discovered a few very important things. First of all, he discovered a positively charged nucleus. The second thing he discovered was that the atom is mostly empty space. So he looked at the atom and he said, wow, I would have thought that the center of the atom, or that the atom had positively charged throughout with these kind of electrons, but that's not at all what I found. And actually, he discovered this quite by mistake. He discovered that the protons are located in the center and make up 99.9 of the atom's weight or mass. In fact, if a golf ball is in the center, the electrons extend 3 miles in diameter, which is actually really fascinating. Here's what Rutherford's experiment looked like. So here's the plum pudding atom. This is Thompson's atom, and this is what he expected to see. He used an alpha particle accelerator, and he shot those alpha particles at a very thin piece of gold foil. It was like 1 atom thick, or I mean, it was probably more like 100 atoms thick. He shot them at this plum pudding model, and he expected the alpha particles to shoot straight through. He said it would have been like shooting a gun at tissue paper, and this is what he expected to find. But what instead he found was when he took the alpha particles and he shot them through this very, very, very thin piece of gold foil, they mostly went through, but occasionally they hit something. And what they hit was that teeny tiny, densely charged nucleus. And when they hit the nucleus, they shot off kind of in the other direction. Now, he was actually really surprised by this. He didn't expect to find that the atom was mostly empty space. So, this was shocking for not only everybody else, but shocking for him. Here is, again, the gold foil experiment. You've got alpha particles, they're shooting at a piece of gold foil. He's expecting them to go right through because he's expecting that positively charged area to be like goo, like plum pudding. But instead, the alpha particles are mostly going through, but occasionally hitting something and going off in the other direction. And you can see here up close what it looks like. Now, the next person we're going to talk about is Niels Bohr. And he stated that electrons have a fixed amount of energy and they're found at specific energy levels. And why did he need to discover this is actually pretty easy to understand. Here is Rutherford's model of the atom. And in Rutherford's model of the atom, he says that there are electrons around the outside. But Bohr came along and Bohr said that doesn't make any sense because we know in elementary school and middle school, the outer electrons would have just fallen into the center because we know that positive things attract to negative things. So Bohr had to improve this model, and he said that we have a positively charged nucleus, and these electrons do exist, but they exist in energy levels around the outside. As the electrons move further and further away from the nucleus, they have more and more energy. Now, Bohr was right about a lot of this, but he was wrong about one important thing, and this was that electrons orbit the nucleus. Electrons do not orbit the nucleus. Instead, electrons exist in what's called a cloud, an electron cloud. So here's the best that we have up to date. This is the model currently accepted. Electrons are found in non-specific paths around the nucleus. And I've got this GIF or GIF or whatever you're going to yell at me for saying that was made in 1999, probably the first one ever made. And I've got a positively charged center, and my electron is around the outside, kind of bouncing around. Now, this is a very simple atom. It has one proton and one electron, and it is simply bouncing around the outside of the atom. And it is not orbiting, as you can see. It's instead a cloud around the outside. All right, so just to review, we had Dalton, who said the atom was a sphere. This was improved by J.J. Thompson, who discovered the first subatomic particle, or the electron. He said that the electron existed in a kind of plum pudding model. And then Rutherford, with his gold foil experiment, said, no, the positive charge is not located throughout. It is in the center, and it is teeny and tiny and dense. And my picture here is terrible because I cannot draw it as tiny as it needs to be on my iPad here. Bohr said, I think you're all right. I think this is great, except I'm going to tell you why the electrons don't fall towards the center. So Bohr showed us that there had to be energy levels all around the outside. And he did a lot more that we're going to talk about in the next chapter. And then finally, they discovered that this right here, this electron cloud, is really what's going on.